this next example, we're going to be given part of an Euler circuit that has been traveled, and we are going to determine how to finish it. Now this problem says to use Fleury's algorithm, so the key thing about the algorithm is just that we want to walk across bridges last. So let's go through and see what we've done so far. So this says start at B and go to H. Okay, so at this point in time I don't have to number the edges, I just want to see what edges I can't use anymore. So I can't use from B to H, H to G, G to J, J to H, H to I to J, J to D, D to I to C, or C to D. Okay, so that's where I would be at. Now we want to choose a possible end. Looking at these options, I want an Euler circuit, which means you have to start and end at the same vertex. Now in this case I started at B, so I need to end at B. So option C is out because it does not end at vertex B. So that can't possibly be the right answer. Alright, so for these other ones, let's see here. They all look the same at the start, E, J, F, E. So I'm going to go ahead and cross those out because that's not going to tell me which one of these is correct. So I'm going to go ahead and finish that. From D, we're going to go to E, then to J, then to F, then to E. So here's where they differ. This one says go to D next. Yeah, I can't do that. I've already used that edge. So this one's no good. Out of these last ones, they both say go to A next, and then F. Now at this point in time, I would not be able to go to J. So that one's out. So this one has to be the right one. We'll go up to G, and then to B to finish this. So that's the only ending that will work. Now in our next example, it says suppose that you are using Fleury's algorithm to find an Euler circuit for a graph, and you are in the middle of the process. So it's kind of like that one we just looked at. The graph shows the already traveled edges of the part, or already traveled part of the graph, which is dashed, and the yet to be traveled part of the graph, which is solid. For part A, it says suppose you're standing at vertex J, so you'll be right here. Which edges could you choose next? So for Fleury's algorithm, it says that you can choose any edge as long as it's not a bridge, unless a bridge is the only choice that you have. So with these dash edges, if you're having trouble seeing what's going on, I'm going to go ahead and make a copy of this. Okay, so you would do this with your pencil. So here's where I can come in and actually remove edges. Maybe get a better idea of what's going on in this graph. So here's a copy of it. So I'm going to come in here and actually remove these dashed lines. They've already been traveled. I wouldn't be able to use them again. So this would be if you're having a lot of difficulty visualizing it, you could come in and take the time to put the whole thing in pencil and then omit those edges that have already been traveling. So for part A, I'm standing here at vertex J. Which edges could you choose next? So could I choose JI? Well, if I were to erase it, does it cause the graph now to be disconnected? Could I still get from any vertex to any other vertex? Yeah, I could. So JI is not a bridge, and so I could pick that one. Now we'll put it back. What about this edge? If I were to remove the edge from J to H, does it cause this graph to be disconnected? Yeah, I can still get from any vertex to any other vertex, so that edge is also a viable option. I could go from J to H. What about this edge from J to G? If I were to remove that edge, is this graph still connected Can I still get from any vertex to any other vertex? Yeah, I could. So from J to G, that's also a possible option. What about this edge right here from J to E? If I were to remove that edge, is it still possible for me to, for instance, get over here from L to over here to I? Yeah, I could still do that. So that edge is not a bridge either. So any one of those vertices are, any one of those edges is viable. So which edges could you choose next? You could choose from JI, JH, JG, or JE. Oh, and that was the last one. So the one that you couldn't pick was JK. That was indicated by the dashed line. That's already been traveled, so you can't grab that one anymore. Alright, so now for part B. Suppose you're standing here at vertex D. Which edge or edges should you not choose next? Alright, so there are 4 edges coming out of D. We don't want to grab any edge that's not a bridge. I'm sorry, we don't want to grab any edge that is a bridge. So does any of those edges satisfy that? So what about this edge from D to C? If I were to remove it, is this graph now disconnected? No, it's still possible for me to, for instance, get from C to I, so that one is okay. What about from this edge from A to D? If I were to move that one, is this graph now disconnected? No, it's still possible for me to get from instance L to H. There is still a route. What about this edge from D to K? If I were to remove it, does it cause this graph to be disconnected? Nope, I can still get from K to, like, for instance, G, so that's okay. What about this edge from D to E? Yeah, that one's going to be a problem. If I were to grab that edge, I'm going to disconnect the graph. So there's no way now at this point in time for me to get from L to, like, H. I've removed the only route kind of across this, this divide between them. So that is going to be the only edge that I should not choose. So I should not choose edge DE. At this point in time, based upon the edges we've already traveled so far, this edge is a bridge, and there are other ways to get out of D, so you only pick bridges last.